Good day, everyone. I am Alyza, and I am here to discuss the behavior of the light as a wave. So, what is light? Light is everything that travels through the electromagnetic spectrum, which ranges from radio waves, microwaves, infrared visible light, ultraviolet rays, X rays, and gamma rays. In 1600s, Mr. Isaac Newton suggested that light was a stream of particles. He also suggested that it was to be called corpuscles. Contrary to Mr. Isaac Newton, Mr. Christian Huygens suggested that light is a wave. It is believed by many people back then that light is a wave because it is pretty easier to show its wave properties than it is being a stream of particles. In support to Mr. Christian Huygens, Mr. James Clerk Maxwell suggested four equations to show how light is a wave. To understand light, we need to know about the electromagnetic wave. Electromagnetic wave is composed of an electric wave and a magnetic wave traveling at right angles to each other. And an electromagnetic wave doesn't require any medium or any substance when traveling through. Unlike the sound waves or seismic waves, it requires liquid, gases, or solids to travel through. But an electromagnetic wave doesn't require any. It just travels through space or vacuum. So how fast does the light travels? The speed of light is about 3.00 times 10 raised to 8 meters per second, and that's about 300,000 kilometers per second. And when talking about speed, it seems crazy fast when it comes to the speed of light. So for the types of wave, we have two: the transverse waves and the compressional or longitudinal waves. So first, transverse waves. These are the waves in which the medium moves at right angles to the direction of the wave. The transverse waves has two parts: the crust and the trough. The crust is the maximum or the highest point of the wave, while the trough is the minimum point or the lowest point of the wave. The second type of the wave is compressional or longitudinal waves, in which the medium moves back and forth with the same direction as the wave. Just like transverse waves, compressional waves composes of two parts: the compression and the rarefaction. The compression is the part wherein the waves are close to each other, and the rarefaction is the part wherein the waves are distant from one another or far from each other. So what does it take to be called a wave? So the wave has four properties. It is the wavelength, the frequency, the amplitude, and the wave speed. So wavelength is a distance between one point on a wave at the exact same place or the point on another wave. The second wave property is the frequency. And frequency tells us about how many waves go past a point in 1 second, and it is measured through hertz. Take note that when the frequency is high, the energy is high as well, so they are directly proportional to each other. So for the third wave property, we have the amplitude, and it tells us about how far the medium goes from the rest position to its maximum position. Take note that the minimum position is called trough and the highest position is called crest. So for the last wave property, we have the wave speed, and the wave speed depends on the medium in which the waves are traveling through. It can vary through solids, liquids, and gases. To calculate the wave speed, we have to multiply the wavelength, which is measured in meters, times the frequency, which is measured in hertz. This has been Alyza, and I hope you learned something from today. Thank you and God bless.